Welcome back to Infra Explained with episode 6, and this one's about keeping your Kubernetes cluster from being an open door. A pod runs your app just fine out of the box, but runs fine and is safe are two very different things. So, over the next few minutes, we'll walk through the 4 basics every cluster needs: RBAC, pod security, network policy, and secrets. So let's name the problem first. Kubernetes, by default, is tuned for convenience. Pods run as root. Every pod can reach every other pod, and service accounts come with permissions much broader than they need. One leaked token in that world, and an attacker basically inherits the cluster. The fix isn't exotic. 4 controls. RBLC for who can do what. Pod security to get off root. Network policy for who talks to whom. And secrets done right. Least privilege applied to Kubernetes. So, if you want the one-sentence version to carry with you, Kubernetes security basics are about least privilege everywhere. That means deliberately limiting who can act, what pods are allowed to do, who they can reach over the network, and how secrets flow through the system. It's the same instinct you already have from Linux hardening. The defaults are open and convenient, and your job is to tighten them down. 4 controls cover the basics, and we'll take them one at a time. Here are those 4 controls on one screen. RBAC, role-based access control, governs who can do what, mapping users and service accounts to permissions. Pod security restricts what a pod itself is allowed to do at runtime. No root, no privileged mode. Drop the capabilities you don't need. Network policy decides who talks to whom, ideally starting from default deny. And secrets keeps credentials out of your images and your Git history. Lock these 4 down, and you've shut the doors behind most real-world Kubernetes incidents. Let's start with Pillar 1, RBAC. The model has 3 moving parts. A role describes what's allowed. A subject is who it applies to, whether that's a human or a service account. And a binding wires the two together. The discipline here is simple but easy to skip. Grant the narrowest role that actually does the job. Reaching for cluster admin just to make a deployment work is how clusters quietly become wide open. Here's what that looks like in practice. This role, called pod reader, does exactly one thing. It lets whoever holds it call get and list on pods. No create, no delete, no secrets, no other resources. If that workload gets compromised, the blast radius is bounded by these 2 verbs. That's least privilege written down in YAML. RBAC controls what an identity can do through the API. But what about the process running inside the pod itself? That's Pillar 2. By default, containers often run as root, so if someone breaks in, they're already root on that pod and one short hop from the node. Pod security tightens those defaults. Run as a non-root UID, mount the file system read-only so attackers can't drop binaries, strip the Linux capabilities your app doesn't actually need, and block privilege escalation so a process can't gain more than it started with. And here's what that actually looks like in YAML. At the pod level, we say run as non-root true and pick a normal user ID like 1000. So the kubelet refuses to start the container if the image tries to run as root. Then, on the container itself, read-only root file system stops anyone from writing to disk, and allow privilege, escalation false slams the door on pseudo-style tricks. It's the same instinct as hmod and non-root users from Linux Essentials, just declared in the spec instead of run on a shell. That brings us to Pillar 3, network policy. Out of the box, a Kubernetes cluster is one big flat network. Every pod can reach every other pod, which means one compromised container can quietly scan the whole environment looking for its next target. Network policies flip that on its head. You default deny all traffic, then explicitly allow what's needed. The web pod talks to the API pod and nothing else. Same least privilege instinct, just applied to who talks to whom. And that lands us on Pillar 4, secrets. Every app needs passwords, API keys, tokens, and the worst thing you can do is bake them into a container image or commit them to Git, where they live forever in the history. Kubernetes secrets keep them separate and inject them at runtime. Treat them as radioactive. lock down read access with RBAC, encrypt them at rest, and rotate them on a schedule. Now zoom out, because none of these 4 pillars works alone. RBAC limits the blast radius if a credential leaks. Pod security stops a compromised app from escalating to root. Network policy keeps one hacked pod from reaching the rest. And secrets keep the keys out of reach in the first place, stack them, and an attacker has to defeat every layer, not just find the one you forgot. Before we move on, let's clear out 3 myths that quietly sink clusters. First, if it's inside the cluster, it's safe. It isn't. Flat networking means one breached pod can talk to all the others, so inside is not a boundary. Second, I'll just grant cluster admin to make it work. That hands an attacker everything on the first slip. Grant the narrowest role that actually does the job. And third, the big one. Kubernetes isn't secure by default. It's convenient by default. Security is opt-in, and turning it on is your job. So here's the cheat sheet side by side. On the do column, scope RBAC roles as narrowly as possible, run pods as non-root with a read-only file system, set network policies to default deny so you opt traffic in, and keep credentials and secrets that you rotate and restrict. On the avoid side, the usual suspects. Cluster admin as a shortcut, root or privilege containers, wide open networking, and secrets baked into images or committed to Git. Same 4 pillars, just framed as habits. Now, which tools actually deliver on those habits? You've already met the big 4. RBAC for who can do what, securityContext for hardening pods, network policy for who talks to whom, and secrets for credentials at runtime. 2 more worth keeping close. Pod security admission, which lets the cluster enforce baseline or restricted pod standards for you. And kubectl auth can I, the underrated one-liner for sanity checking what a role can actually do before you ship it. So if you take nothing else away, take this. Kubernetes ships convenient, not secure. Closing that gap is the job. RBAC means granting the narrowest role that still works. Pod security means non-root, read-only file systems, and dropping capabilities you don't need. Network policy starts with default deny and opens paths deliberately, and secrets stay out of images, locked down and rotated on a schedule. And if you compress all of that into one mental model, it's this. Kubernetes is default open, and your job is to tighten it. Least privilege at every layer. Who can act, what a pod can do, who it can reach, and how secrets flow. In a default cluster, everything can do everything, so one breach is game over. In a hardened cluster, each layer is narrow, and a breach just hits a wall. And here's where this episode ties back to everything we've built so far in the series. Pods from episode 5 are exactly what you're now securing. Linux users and permissions, that same least privilege instinct is what drives non-root containers. The security fundamentals we covered, OWASP, secrets, hardening, all map directly onto Kubernetes. And networking becomes network policy, just segmentation for pods. These basics close the common holes. Real-world hardening goes deeper, layer by layer. So where do you go from here? If you want the full picture of how infrastructure fits together, the Infra Explained series walks through Docker, Kubernetes, CI/CD, infrastructure as code, and the security basics we just covered. And when you're ready to take K8's hardening seriously, RBAC design, pod security standards, network policy, admission control, supply chain, the Kubernetes Hardening Mastery course goes deep, hands-on, over at dargslan.com courses. Before we wrap, I've got a question for you. Of the 4 pillars, RBAC, pod security, network policy, or secrets, which one would you actually turn on first in your cluster? And be honest about it. Have you ever shipped something with cluster admin handed out everywhere just to make the pipeline go green? Drop your answer in the comment. I genuinely want to know where people start. And that's a wrap. You've now got the mental model to both run and secure workloads on Kubernetes. RBAC, pod security, network policy, and secrets, all pulling in the same direction of least privilege. If you want to go deeper, From the fundamentals into real production hardening, the full Dargslan course over at dargslan.com is your next step. Hit subscribe, and I'll see you in the next episode.